Hello and welcome to the Oxford MAT Livestream. It's great to have you with us. We're going to talk today about some sequences and series. But first I want to say hi to people who are joining us live because you're here. It's great to have you with us. Shout outs quickly to Harriet and Ramanajan and Farhan and Nikita Mazepin and other people in chat as well. I can see some anonymous people and some people have set their name. If you want to join live chat, if you're watching live, you can do that over at slido.com/MATLIVE. And we've got more people here. JWC's here, Lothar, 3 blue 1 brown, probably definitely them, not them, not definitely them. Other people are checking in as well. Hi everyone else. Brilliant stuff. Right, okay. If you're watching this for the first time, which is likely because this is the first video in the series, this is going to be a weekly show where we talk about things for the maths admissions test. We're going to work our way through the syllabus of content that's on the maths admissions test syllabus, and we're going to try some warm-up questions and also try some questions from the actual mat. The warm-up questions were written for this program last year. We're running them again, and the idea is that we get between sort of A-level revision, or if you haven't seen it yet, then A-level learning or equivalent. We get between that and doing some mat questions afterwards as well. There is a little bit, I can see in chat here, there is a little bit of off-syllabus maths as well. Oh, chat's lagging. Am I doing something wrong? I am. No, I'm not doing something wrong. Good. Okay. The live stream is also, so changes from last year, and I saw this in chat a little bit before we went live. I saw this in chat a little bit. What's the difference between this year and last year? Well, mostly I changed the number, look. Now it says 2 at the end here. So that's different. And also we fixed some typos. We changed the sheets a little bit. But mostly we're running back exactly the same content. I'm doing that on purpose because if you saw this show last year, if you already saw the MAT livestream, then I think it's probably a good idea for you to maybe do something else. If we did a slightly different MAT livestream, then I worry that you would try to watch all of it. Whereas here, if I do it exactly the same again, then you know what it's going to be. Good. Is this good for beginners? Says someone in chat. It's Abby, and I think maybe yes. So we're going to do some revision. I've called it revision on there as well, but there's no reason that you can't learn during the revision section. Let me outline quickly then 3 ways that you might join in with this content. There are kind of 3 ways to play. The first is that you might be very keen and you might do the worksheets in advance. Why am I writing in capital letters? That's not going to last. Oh, it's very tidy though, isn't it? I'm going to stick with that for now. You might try the worksheets in advance. The worksheets are on that website down there in the bottom corner, and link in the YouTube description, and just with links everywhere, hopefully. On the MAT Live homepage, you can find the worksheets. You could try them in advance. Last year we dropped them one at a time, I think. This year we've just put all of them up. So if you want to just get ahead and have a look at the material, then you can grab that. It looks a little bit like this. You see there's a bit of syllabus at the start, and there's some revision questions, some revision materials, some warm-up questions, and some MAT questions with hints. So you could try those in advance if you want to. That's one way to play. But there's another way to play where you don't do that and you join in live. We're going to go through the questions live, and as we go through them, we're going to talk about them live here and now. This is actually how I'm joining in. I haven't tried the worksheets very recently, so I'm going to be joining in live to try that out. There is also a third way where you have already done the MAT live stream, or you already know all of this maths and you're just sort of hanging out. And hanging out with us to see some maths happen and to chat about maths. That's going to be one also thing there as well. Brilliant. Look, okay, Dammy says, no access to PDF version of worksheets. No, what? No, that's not brilliant, that's bad. No permission to access the PDFs. Okay, that's a big problem. Does anyone, okay. So somebody's posted a link. Now, I wonder if they've posted the link without being able to access the PDF. This is why I did the web version as well. There is also a website version. Okay, we'll see if anybody can get it. So some people can access PDFs and some people can't. Okay, PDFs are a bit old-fashioned. We made the PDFs because They look pretty, and they're good for printers. You're not a printer though, so we also made a web version that might be a little bit better on, I don't know, mobile phones or something. Downloading PDFs on mobile is just not very good. But anyway, so just going through them live. I mean, you can't use the past papers question. Probably is if you've already seen some of the questions. We've restricted which past papers we've taken questions from. So we've only taken questions from, I'm going to get this wrong now, up to 2017. And actually only starting at, I think, 2012. 2012, 13, 14, 15, 16, 17. Not even sure I used 2012. So just a few past papers. 13, 14, 15, 16, 17. We're saving 2018, 19, 20, and 21 for at the end. We'll do those together as a past paper. What we're going to do is only cover those questions during the MAT live stream. So there'll be some things that you've seen before and some things that you've saved. There are also some older past papers out there. 3 Blue 1 Brown appreciates PDFs over Word documents, and I didn't even really consider making everything in Word. Thanks for everyone linking to the worksheet if you want to play along. The numbers in the worksheet, the first number is a 0 to get them in the right order, if you sort them alphabetically. The last number is a kind of version control thing. So there we go. Yeah, I'm not sure that one's going to work, but cool, I'm going to go for that. It is 2 hours today. Something we realised last year was that we did 1 hour and it was always really rushed and it overran a little bit sometimes, and there's bits and pieces which we didn't do. So this year I've blocked out 2 hours to try and do it properly. We will see. Yeah, I use LaTeX. I use LaTeX to write them up, and then I convert them to more plain tech for MathJax. Anyway, too much information. The PDFs look very similar to the ones from last year. Yeah. Okay. What I've done is I've changed the number from a 1 to a 2 on the end. Yeah, they are the same worksheets. If they're not broken, don't fix it. These are once a week. This is Thursdays at 5 p.m. to 7 p.m. UK time. And warning in advance for international people, at some point in October, the clocks change in the UK. We do something called daylight saving time, which might change what time it is compared to your time zone. We're going to do this once a week. Cool, right, good, okay. Danny Rick here is just a big fan of just LaTeX in general over everything else. So that's good to know. People picking up, so people's usernames, by the way, in Slido, don't read too much into them. People seem to have a little thing going on here to do either names of mathematicians or Formula 1 drivers. Yeah, I think you may have started that, Nikita Mazepin, or person using Nikita Mazepin's name. Right. Yeah, there we go. Okay, right, cool. Right, I need to stop reading chat and start doing some maths. If you're watching afterwards, there should be links in the description below if you just skip past all of the chat and just get onto the bits of mathematics, which you might be interested in doing. So let's put this up here. Is it too late to be starting mat prep? I really hope not, because if it's too late to be doing this, then I'm wasting 2 hours of my evening. The plan is that it's not too late. The plan is that we're doing this. Brisbane's not here today. I am moderating chat. And what happened to VMOX? Hey, see, about a term ago, everyone was saying what happened to Slido. We've been using Slido for a couple of years. We had a term off, and now we're back in Slido. Gotta love that. Right, let's go. Okay, so we're going to cover the topics on the MAT syllabus for sequences and series. That sequence is defined iteratively and by formulae. Some people say formulas with an S, which is also fine. Arithmetic and geometric progressions, which we're gonna do as well. Sums of those things and convergence conditions for those as well. Yeah, no one's asking what happened to panopto. Good, right, okay. Let's go then. So sequences might be defined like this, where you're just told a formula for the nth term in terms of n. So something like an is n squared minus n. You can use that to work out some terms of your sequence. Like a1 with m, 1 squared minus 1 is 0. 1 take away 1 is 0. Welcome to the Oxford MAT Livestream. And things like a2 is 2 squared take away 2, which is 2. A3 equals 3 squared take away 3, which is 6. And you could keep working those out if you really wanted to. Right, people have made some important observations in here. One of them is that I always, at the start of these, turn on a poll to say, how was your day? Which I forgot to do, which was very rude of me. So I'm going to turn that on now. It's a 5-star poll. How was your day out of 5? And as always, I'm looking out, first person in voted 5. I'm looking out for people who vote 1 or 2 in the hopes that your day's not going brilliantly so far. And maybe we can do some sequences and series, and that might be better than 1 star. That's what I'm aiming for, better than 1 star. Git, right, cool. I'm going to keep working out terms of this while we're voting. The first time we did this, we actually did this 2 years ago as well. And the first time we did this series of episodes, I've managed to do 4 squared take away 4 wrong, haven't I? No, I haven't. I'm good. That's twice. Yeah, good. Sorry, the first time we did this, we used a program called Panopto, and we had voting going on as well. And the live stream was just 2 hours. Most of it was me silently doing the questions. It was a very strange experience. Yeah, Denim's right here. Let me just quickly show you what Denim said in chat. You can't see behind the poll. I can't work out how to turn it back again. Right, cool. Denim, I'll read out your comment. Is that twice the sum of the integers from 1 to n-1? And an anonymous person says, is it twice the triangle numbers? And you're both right. This sequence is a sequence you have maybe seen before, or is related to a sequence you've seen before. If you want the worksheets, someone in chat asks, where are the worksheets? There's a website on screen and a link in the YouTube description. If you look up the Oxford MAT Livestream, there's a homepage where you can get not just this worksheet, but also the other 9 worksheets for the next few weeks. It's fine. There's a website on the screen. Oh my goodness, that's amazing, Adrian. Adrian, that's brilliant. Right, cool. Yeah, and it's also the product of 2 consecutive numbers. Oh, I like that one too. Right, cool. People's days are going amazingly. People are getting 4 stars. Is it the holidays? It is the holidays, isn't it? Good old holidays. What are they like? 4 stars, that's pretty good. I think my day has been 3 stars so far. I'm hoping that doing a bit of live streaming gets us up to 4 stars. Will we go over some 6 or 7 during the course of these videos? Yeah, so we normally do 1 episode that's very computer science themed. And I'm maybe going to get the computer science department to help me out with that one, to do some question 6 stuff, and do some question 6 and 7 questions. We're not making very fast progress through these questions, are we? Colats has put their conjecture in chat. Thank you, Colats. Git, right. Okay, so we might have a sequence that's defined just by telling us what the numbers are. The little subscript down here, people pronounce this AN, like in chemistry where you've got subscripts. But in chemistry, the subscript means something very particular. It means how many of that atom you've got. Here, we're using the subscript to mean that's the nth term. So our sequence goes A1, A2, A3, and so on. Some people like to start with A0, but sometimes A1. People are putting a link to the worksheet in chat. That's very kind. Thank you. What's the difference between this and the Maths Club? Well, we've changed the colour scheme. It's got a different colour scheme. Did you notice? And joking aside, we're now only talking about maths admissions test questions, which we tried not to talk about on Maths Club. But hey, look, it's still me in a square. Will it vary between A0 and A1? I think maybe it will. Maybe we've got no guarantees about whether my sequences on the mat will start with A0 or A1. I think either's acceptable. Pay attention. We're not trying to trick you. Just there isn't really a consensus on how you're supposed to start. Okay. So triangle numbers, by the way, triangle numbers. I love triangle numbers. Look like this. You draw these little right-angled triangles with dots, and you count the dots, and you get 1, 3, 6, 10. There's a formula for these, which is n times n plus 1 divided by 2, where n is the biggest thing you added, that's a sequence that comes up in some places. The difference here is that you sort of go from this one you add 2, to get to here you add 3, to get to the next one you add 4, and these kind of look like triangles. Even the small one looks a bit like a triangle if you squint. So those are called triangle numbers. Right, not really important right now. Let's focus. Okay, so a sequence might be defined by a relationship where you're told something in terms of the previous term. Don't actually put your personal statement in chat. That will probably be plagiarism. Also, I don't think it fits in the character limit. Good. Okay. So we might be given some sort of function like the function might be square it and add 2 or something. So then my function applied to some starting number might be something like a0 is 1, and then a1 would be f of a0, so f of 1 would be 1 squared plus 2 is 3, and then a2 would be something like f of 3, which is 9 plus 2 is 11. And then we can keep working these out. And this is like how the triangle numbers here have some relationship to the previous triangle number. Oh, you can't see where I'm pointing. Let's see if I can fix that quickly. That's better. The triangle numbers up here have some relationship to the previous triangle number. Sometimes that's a helpful way to think about the series. Yeah, so people really want off-syllabus stuff. Hi, Joe. Should A0 be 2? Oh, goodness. Well, I don't know. Depends where we are. Good. So A0 could be anything because it doesn't. A0, I see what you mean, Casey. A0 could be anything. What you're doing is you're putting in the number 0 as x equals 0. But really, this relationship just tells us how things are related to the previous one. It doesn't have to be related to the number n. An can be something completely different from the number n. So here we started off with a0 equals 1. We could start off with anything for a0, and then generate the next term and the next one as we go through. Practicing maths is great and really good fun. I said right angle triangles because that's how I drew them. I realise now people in chat are a little bit unhappy about this, and people in chat want to think of these as equilateral triangles. I think of them as right angle triangles, I think, although the geometry is not really important to how many dots there are. I think of them as right angle triangles because I think of them as 1 next to 2, 1 next to 2 next to 3, 1, 2, 3, 4, lined up, ready to be added together. But I guess you could think about them as equilateral triangles with rows of those things. What's my favourite triangle number? Probably 1. Are we going to have a personal statement 1? Probably not. No, I think we're just going to do maths if that's all right. Good. Oh, bowling pins, yeah, or snooker. Pool. They also do lining things up like an equilateral triangle. Maybe that would be more culturally resonant if I did them as an equilateral triangle, because people would think about snooker. All the kids love snooker, right? Okay. I am aware I said I'd focus about a minute ago. And now here we are. Right, okay, what are we doing? We're generating terms of a sequence. Okay, so joking aside, this is quite a good way of being able to describe a sequence just by relating it to previous values. And then if we need to, we can go and calculate those values. Are there personal statement videos online? Yeah, if you look on this YouTube channel and you scroll all the way back, then you can find a video with my personal statement in it, which would be very good. Chat is very distracting. It's distracting for everyone. I'm going to look at chat slightly less frequently, I think. There's this notation for adding up terms in a sequence. And then I wanted to define a couple of important sequences. One of them is an arithmetic sequence, that's what it's called. There's a first term and there's a constant difference where you add on a certain amount each time. That's sort of how the triangle numbers work. The triangle numbers are an example of an arithmetic sequence. But in general, you could start with any number a, and you could add on any common difference, d for difference, adding that on each time. And these would be the terms in the sequence. Really need to get chat moderation back, don't I? Someone else moderating chat was definitely a good idea. Okay, there's a formula, which for now I'm just going to put on the screen and say here's a formula for what you get when you add together the first n terms. So let's quickly write out that sum of an arithmetic sequence here. A plus 2d, a plus 3d, plus, and then a plus n minus 1d. Being really careful that that's the nth term of an arithmetic sequence, not a plus nd, because there's an a plus 0d over here. The sequence is sort of 0 indexed, if that means anything to you, which means that if you want n terms, you write down n minus 1 for your last term. Okay, there's a formula for what happens when you do that sum, which is n over 2, it's just up here, times 2a plus n minus 1 times d, which is how I've always seen it written in textbooks and things and when I learned it in school, but maybe it's helpful to think of it as an times d times n minus 1 over 2. I find this a more helpful way where you've got a term that depends on a and a term that depends on d, and they're quite separate and they behave in slightly different ways. And maybe that's a helpful way to remember it. I don't know, up to you. Yep, good. Where did I get the version of the PDF with spaces to write? Asked Alfie. I made it. That's what I'm up to. If you want that, then I don't know, send me an email or something, and I might put them on the website. I made it for me to write in the gaps. There we go. But it increases the number of pages, which is probably bad for the environment or something. If everybody prints a very long version, I'm getting distracted again. There's another sequence I'd like to explain to you, which is the geometric sequence. It's a very similar idea actually. You take a first term, but instead of adding, you multiply. And normally people write R for ratio on these ones. So your first term's A, and then your next term is A times R, and then A times R squared, because that's multiplied by R again, A times R cubed, and so on. These turn up in lots of different places, including a lot of geometry problems. They're just quite helpful. It's a good thing to know about. They turn up a lot at university because we know some facts about geometric sequences, and being able to compare other sequences to geometric sequences is quite a good way to be able to say things about other sequences. It's nice having sequences that we know things about. At university, there are a bunch of sequences that we don't know very much about at all. So being able to say what I'm about to say is considered a strength of geometric sequences, I suppose. We know this formula for adding together the first n terms of a geometric sequence. I'm saying I know it because I learnt it at A level. If you haven't seen it yet, then here's a surprising fact that you can do that sum. So here's the sum. I'll put a pink box around it. A plus AR plus dot 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 plus A R to the n minus 1. We're being careful again. This is n terms of the sequence, with the last one being R to the n minus 1. That sum has a very nice formula, a very sort of simple formula, and there's a quick proof on the screen there about how you might work that out. How you might work out what that sum is, but ideally, rather than writing out this line of algebra or something, you might be able to remember that expression over there. If you've seen the thing about 0.9 recurring, or if you've done some stuff to play around with, let's not talk about 0.9 recurring, if you've done some stuff to play around with fractions like this, so recurring decimals, to write those as fractions, then you might have seen something like you could multiply that by 3 and then get exactly the number 1. Yes, it's interesting that it works really well. Well, it's my favourite sequence. I have no idea what my favourite sequence is. Great username though. I should probably say something clever to do with Nerza. Anyway, getting distracted. This is 1/3, by the way. Let's not leave that as a question. That is exactly 1/3. Okay. So nice formula for adding these together. If you haven't seen this at A level yet, you will at some point learn this at A level. There's a proof on the screen that if you've never seen it before, you've seen it now. Good. Okay. Here's what I want to tell you then. There's not very much infinity in A-level mathematics, really. There's not very much stuff to do with, these are called limits, where you replace something with, making the number larger and larger, and imagining what would happen if the number got extremely large. What happens to that formula up at the top, if n is really large, well, we kind of know what's going to happen to r to the n. R to the n is some number r to the power of n, which is getting very big. Now, if r is bigger than 1, if it's, say, 2 or something, then 2 to the n gets really big, exponentially fast, really huge, which is sort of quite bad news for us to say anything sensible about that. That actually makes sense. If we've got these things added together and they've got all these powers of 2, then adding together infinitely many of them doesn't really make sense. So that's kind of to be expected, I suppose. But if the number r is smaller than 1, well, let's be careful. If it's between 0 and 1 to start off with, if it's between 0 and 1, then this r to the n, when n is really big, gets really small. That's quite interesting. It means that, and there's some interesting maths behind the scenes that we're not really talking about, but that's okay. The sum to infinity, if you want all of the terms, which is sort of written like this, ar squared plus ar cubed plus dot dot dot, where you're supposed to imagine all of the terms going on forever, the sum to infinity, then if that ratio r isn't bigger than 1, and it also turns out if it's not less than negative 1, then you can say that the r to the n bit there in the previous expression is is a over 1 minus r. It sort of simplifies down a little bit, which is quite nice. And this is a different r number from the, is it a sort of similar r number to the COVID stuff? It's a different thing. The R in COVID stands for reproduction number, right? Is it? Whereas this is the ratio, but sort of similar idea of exponential growth rate. Yeah, people are very excited about infinity in chat now. I sort of thought that was going to happen. I mean countable infinity on the integers, but that's not important right now. Okay, if I was picking the one, then the sum we say it doesn't converge, doesn't do anything sensible as the numbers get bigger. This is a great fact. This lets you do sums like this for being careful, 1 over 16, 1 over 32, and so on. I think I'd actually seen this before A level at some point, but this sum is exactly equal to 2. It's got this first time 1. It's got r is 1/2, so it's sort of 1 over 1 minus 1/2, which is 2. So that's quite a nice fact. One way to imagine this is that it's sort of 1 plus halfway between 1 and 2, and then halfway again between 1 and 2, and then halfway again, and then again. If you did infinitely many of these steps, whatever that means, or if you did lots of them, made the lots of them very, very lots, and then it's exactly equal to 2. Oh my goodness, grant sinus and topics. So converge is a word, I suppose, kind of an English word that just means gets close to. Numbers getting, the idea is that as you add in more and more terms, with n getting bigger and bigger, imagine an n at the top of this sum, n getting bigger and bigger, then the answer for the sum gets closer and closer to 2. Right, good. Aha. Yeah, there's a paradox about this called Zeno's paradox, and there's something to do with tortoises and people running away. You could look up the Zeno's paradox if you want to find out more. This is not the maths club though, so we don't go and talk about Zeno's paradox for a long time. Right, cool. That is basically all the content that you need for sequences and series on the maths admissions test. You don't need to know further maths content for the maths admissions test for Oxford. You don't need to know other bits and pieces, and you don't really need to know the proof. It's probably good if you've seen the proof in your life, and you have now seen the proof in your life. Here it is over here. But I don't think reciting the proof would be a very interesting thing to do in a math question. Yeah, it gets really close to it, but that's an interesting thing to say. That's what I'm trying to say here. So this equals sign is a little bit dodgy, and the ... is a little bit dodgy. At university, people learn a more precise way to say how this sum gets close to 2. It's never actually equal to 2 for finitely many terms, but it does get close to 2. And getting close to 2 is something interesting that it's worth coming up with language to talk about how it gets close to 2, even though it's not exactly 2. It's interesting. Good, right. Why is it 2? Well, it's the formula that I've got here. It's the shortest possible answer. It's the formula above here, right? With a equals 1 for this first term, and r equals 1/2 for the ratio between the terms. And then, brilliant, that's 1 over 1 minus 1/2 is 2. Infinite sum summation, so in order to actually properly prove it, you need to know a little bit about what it means to converge, which is definitely university maths. Proving this is obviously not on the maths because it's not on A level. Brilliant, it is 2, it is 2. Good, right, if you look around though, you can maybe find, if you're interested, some people in chat have started talking about Greek letters, epsilon and delta, which is very exciting to me, but I've got to not get distracted by all the epsilons and deltas. There's some kind of formal language of mathematics that people use to explain facts like this without using hand-wavy stuff like ... and these equals signs. Let's not, because most of the proof is me defining the word converge, which is not very exciting, and then once I've defined it, to check that the thing I'm claiming is actually true, which is not very good. Why doesn't it ever go over to, yeah, it feels like maybe it should, right? Because you're adding together loads of things. Shouldn't it just go really big? No, surprisingly, it's exactly 2. The things you're adding, in their defense, look, they do get small, and they get small very fast. You take a big step, and then you take a small step, and then a tiny step, and then a really tiny step, and then some more. And some more steps really, really tiny, even though there's loads of them. Proofs of Bay, the entire person. That's not an entire personal statement. Complete chaos, yeah, well, chaos is sort of the brand, right? That's sort of what we've got going on here. Oh, we already worked out some terms here. We already worked out A3. We already worked out A3 was 6. We're doing the warm-up questions now. This is happening. Good. I'm just catching up with chat, sorry. Common ratio is just one term divided by the previous term. We did division, right? So one term divided by the previous one. So in that sequence, I could see that 1/8 followed 1/4. 1/8 is half of 1/4. And if it's always the same, we've got a common ratio. Good, right, good, okay. We are off the rails. The rails are so far away that no one can even see the rails anymore. Am I going to do all of these? I'm not sure I'm going to do all of these. So some calculations to do here to work out what's going on with this sequence, and to practice doing some calculations. Here I'd like you to work out the difference between two terms. The solutions to all of these questions are also on that website in the bottom corner, the same place where you can get the questions. Last year we experimented with dropping the solutions one at a time. This year we've just dropped all of them onto the website, except for one of them, which is broken. The interactive version for maths candidates on Unique is available on Canvas now. If you check the Canvas page, if you're on CS for Unique, then you're getting it soon. And if none of those acronyms meant anything to you, then don't worry about it. Maths people should have it now. I love this question so much. This is my favourite question. Am I forced to watch this live stream, or is it voluntary? That's amazing. Right, okay, can't understand what limits are. I have a remedy for this, which is that university maths will sort that out for you. Studying maths at university would be a really great way to find out what limits are. For this test, maths admission test, definitely don't need to know what a limit really means. There's this thing that people say about geometric series, which we just had on the screen. But otherwise, not important. I'm going to skip this kind of algebra. I've set you some algebra and then I'm going to skip it. This one's got some common difference going on. So it's got A0 is 1, and then A1 is 4, and then A2 is 3 more again, and then A3 is 3 more again, which is 10. And we've been asked to add these terms together. We could do that very slowly by working out all of the terms and adding them together. I mean, that's fine. Or we could recognize that this is an arithmetic sequence. And we could use the formula that we had just a couple of pages ago. If that doesn't make any sense to you, then go and look at the revision material, find a formula, recognize why this is an arithmetic sequence, find out what the common difference is, plug things into the formula, then check your answer. Also here, finding A1000, please do not calculate 1000 values of this. Good. Having trouble with the canvas. I might not have published it properly. On the homepage there's supposed to be a link. Sorry, this is the only way I have to debug this. On the homepage for maths, unique maths, there's like a unique canvas. Oh no. I'll go and look at it afterwards. Do we need to memorize these? You'll be slightly faster at questions like this if you have memorized it. Some of the other people doing the math have memorized it, which will make them slightly faster at doing these questions. And I think that's probably a good idea. Danny Rick, I know you are all about speed, and what this is an opportunity to be slightly more speedy. It's not a very hard formula. You'll be okay. And if you do question 11 on this warm-up sheet, you learn a reason why it's true. This is a geometric series. I'm completely skipping this. This is an example with a geometric series. Warm up if you want to warm up. Things are being divided by 3, and we're going to add them up using the formula that we just learned a minute ago. And here again, so this is actually slightly important, so I'm going to do this one, I think. Or actually, yeah, I'm going to do this one. So sometimes things are related to the previous term like this, and 3 times the previous term plus 1. 3 times 4 plus 1 is 13. 3 times 13 plus 1 is 40. Really hope I got those right. So here I've got a sequence AN and then a new sequence BN. And the game here is we're going to try and make them equal to each other. AN is the sort where we're told the relationship between terms, and BN is the sort where we have a function that generates the terms in terms of n. So what would that be? That would be A0 is 1, so B0 on the other hand would be A times 3 to the 0 plus B. Aha, that's A plus B. and b1 would be a times 3 to the 1 plus b. That's 3a plus b, using this formula, right? So we've got these two sequences going on. The first one, a ends. The a ends go like this: a naught is 1, a1 is 4, 13, 40. And I've got these b's as well. This b sequence in terms of capital A and capital B, and we would like these to match up. So I guess I would need a plus b to be 1, and I'd need 3a plus b to be 4, I suppose. So if I can match those up, then that would be really good. What's the timing like? Oh, math questions. Oh, math questions. I'm going to let you solve this algebra or tell me that I got it all wrong while I catch up with chat. There's no formula sheet for maths, and the timing is 2.5 hours. You do 10 multiple choice questions and 4 longer questions in 2.5 hours. People normally spend under an hour on the multiple choice questions, I think, and the rest of the time doing the longer questions where you need to show you're working out. We only do particular courses at Oxford due to not actually having a huge number of students. I have locked the Canvas thing. Thank you, Canvas. Thank you, unique people. I will go and work out how to unlock it. Good, right. How many IB mathematicians? Quite a few. Don't know the number, sorry. Some people, strong opinions about starting from A0. Give that one a thumbs up if you also hate it when series start from A0. Yeah, so I would guess B is, so the difference here, B is 3? Is A minus 2 or something? No, that's terrible. That's not how you solve equations at all, is it? Oh, the difference is twice A, which is 3, so is it 3 over 2 then for A? See if people agree with me. B is then going to have to be minus 1/2 to solve that. Good. Alfie agrees with me, SV agrees with me, James in chat agrees with me. Good. James on the screen agrees with me. Right, good. Yeah, super locked. Sorry. I have not left enough space for working. Oh, you mean on the actual math papers, you think there's not enough space for working out? I hear you. Okay. Fair comment. Opinions on zero indexing are coming into chat now. There they are. Good, right. There's a harder version of this question. So if you just saw this and thought that was too easy, I've put a harder version in the warm-up as well, which I've decided not to warm up by doing this one. But if you're watching along at home, you could try this one as a warm-up. This turned out to be in terms of A0 and A1 really, in terms of these things. If we've got 3 variables going on, maybe we could do something to do with the first 3 terms. Good, right, okay. There's something like this coming up in one of the math questions when we get onto those. This is exactly what happened last year, that we would get slightly sidetracked and then never get onto the maths questions. This is why we're doing the extra hour. I'm skipping this. No, I'm not. This is important. Look, it's the sums of the powers of 2. So the geometric formula, the first one that we saw there, what you can do is you can use that even if the ratio is not between -1 and 1. If the ratio is between -1 and 1, there's this lovely result about the sum to infinity of all of these terms, which this question is going to be about down here. Even if it's not, then you can still write down things like this. To say, what have I got here? My first term is 2, my common ratio is 2, I can see there's a common ratio going on, each one has been multiplied by 2, and I need to be a little bit careful. This is n terms, isn't it? This is n terms. What do I want? I think I want 2 to the 1 times 1 minus 2 to the n. Oh my goodness, I've overthought this. 1 minus 2? I feel a little bit sketchy. Maybe I should have written down 2 to the n minus 1, 2 minus 1 at the bottom there. Let me just have a quick think. Yeah, about twice as big as 2 to the n. That's a lot of thinking. You said bn. You worked out the bn was 3 times bn minus 1 minus 1. That's very clever. I like that. Does that then tell you how? So that tells you how the relationship works. Does that give you the numbers a and b from there? You know the relationship for the a's. Okay, just do the whole thing the other way around. Yeah, some matrix stuff going on. Matrix stuff. Space working out. So the question booklet is also the answer booklet. It's got some space for you to work out, and you're not really supposed to use blank paper, spare bits of paper. You're supposed to answer in the booklet. if your handwriting is big enough that you want a modified test paper, then if you get modified test papers for other things, then you should maybe get a modified test paper for math as well. Not just maybe, sorry. Yeah, this is making people unhappy. Good. I'm getting really scared about my factors of n and stuff because it will look embarrassing if I get this wrong. No, we're good. I have to really concentrate for what the, you write down, there are n terms, so you write down ratio to the n in here. It just looks weird because that last term is 2 to the n, but that's because I've tricked myself. Yeah, people are very keen on multiplying top and bottom by -1 in that case. Just doing a quick poll. I thought this would be a good use of our time today. If you could just let me know, that'd be great. Oh my goodness, what is this? Powers or something. Yeah, making mistakes is one reason to have paper, I suppose. Although if you make mistakes, crossing it out in a way that people can still read it is good. Somebody asked earlier how the marking works. We get MAT marked by graduate students. They're pretty good at spotting times when people are doing something clever. This is another geometric progression, geometric sequence. Here's the sort of questions that we can ask you about arithmetic, about geometric series and conversions to convergence. Here's a geometric sequence. Here's the first term is 1, and the ratio is x cubed. So what you need is, that ratio, the thing that I've been saying is you need that ratio to be between -1 and 1. Another way to write between -1 and 1 is to say the absolute value is less than 1. That means that we need here we need mod of x cubed to be less than 1, which does actually mean that mod x is less than 1, which is the sort of thing we might have written down anyway. But hey, it is also true. How's that poll doing? Poll doing all right? Oh my goodness, the poll is very close to 50-50. A1 slightly winning. That surprises me a little bit. I've been trying to do more zero indexing recently. That's why today's worksheet starts 0 SEQ. But goodness, right, okay. Good stuff. Oh look, one person said this is genuinely fun. I do wonder sometimes. I do wonder. Right, okay. Here's another geometric series. So what we've got here is a slightly confusing one. 2 minus x at the start here. That doesn't look like a geometric sequence at all. And then x squared over 2. Goodness me. Who knows what's going on here? I suppose it's just about possible to notice that this is a common ratio, kind of in disguise, of negative x over 2, which is a bit of a mad thing to do. It means that the first term is 2, right? And the common ratio is negative x over 2. So that's how you get a 2 at the front, and then a minus x, and then a plus x squared over 2, and then minus x cubed over 4. So we can just plug this into our formula. Oh, well, let's be careful. We would need the ratio to be between -1 and 1, and that happens here if the size of minus x over 2 is smaller than 1. I'm saying size of interchangeably with the absolute value of, interchangeably with, I want this thing to be between -1 and 1, right? I want the size to be, I want it to be nice and small. Between -1 and 1, please. Which I think is the same thing as saying that the size of x is less than 2. Which would mean slightly better, isn't it? The powers of 2 in the denominators here mean that this converges slightly more permissive. You can set x to be bigger values up to 2, and it still converges. That is called a ratio. Let's not say what that's called. In MAT 22, sequences will start in A0, says somebody in chat, which is quite a bold prediction, isn't it? We're going to be okay either way. 50%. Oh, it's got not just heated. I think it's gone a little bit beyond heated. Good. Okay. There's a link in chat which I'm going to very quickly moderate. I definitely need to get chat moderators again, don't I? That was very daft. That's an opinion piece on 0. Right. Okay. Yeah, it's getting heated. Where did the minus x come from? Well, I noticed that each term was being multiplied by a factor of x to get the powers to go bigger, but it's also been multiplied by -1, which is giving us these alternating plus and minus signs. Could you also say that the first term is 2 minus x and the common ratio is x squared over 4? Yes, you could. That's a great idea. Oh, I like that. I'm not quite sure how you spot that. I mean, it's true, but sure. This next term here is then 2 minus x. Yeah, so then it's common ratio. Cool. I bet that gives the same answer for the sum. Good. Okay. If you put some complex numbers in, chat loves complex numbers. Chat really likes complex numbers. If you put complex numbers in, then there is something else going on in here. There are no complex numbers on the maths admissions test. I tried to balance it out by talking about complex numbers quite a lot on the Oxford Online Maths Club. There are no complex numbers on that, so we're not doing complex numbers today. The inequality didn't flip. The minus sign in here, it is fine, I promise. I'll explain why. The minus sign inside here, I'm allowed to get rid of it, because what that's saying is that negative x over 2 is supposed to be between -1 and 1. But that's the same thing as saying that positive x over 2 is also between -1 and 1. It is safe, really. And then I multiply both sides by 2. So it didn't flip because of the modulus signs. There's inequalities coming up in a future episode where we will be very careful with minus signs and inequalities. But here, I'm not really multiplying either side by anything. I'm saying something about the left-hand side, that the size of negative x is the same thing as the size of x. A0 is literally only acceptable in CS, and even then, barely, says somebody in chat. Oh my goodness. Right, okay, good. Did that poll finish? Did I stop the poll? I did stop the poll, good. We're not doing complex numbers today. So to converge just means that this sum gets closer and closer to a particular number. It only does that for some values of x. As an example, if you plug in x equals 1, that satisfies this condition that we found. So for x equals 1, this is the sum 2 minus 1 plus 1/2 minus 1/4 plus 1/8 minus 1/16. And it's not very obvious that that gets closer and closer to a particular number, but in fact it does. That gets closer and closer to the number 1 1/3. I thought I'd start talking and hope that I could work out what it was while I was talking. I think 1 1/3. My goodness. Yeah, extra things. Yeah, who knows? Right. Okay. This is very controversial. Nobody's starting their sequences from A2, not on my watch. Right. Okay. Good. Okay. Good. Right. Cool. Okay. Yeah, so converge. There's a great description in chat. Thank you, anonymous people. I really like it when people post things in chat to explain answering other people's questions, because it means that I don't have to. You're doing my job. Good. Right. Cool. Applications to do the rest of my job are welcome. No, they're not. There's a proof here for question 10 to explain why the formula for arithmetic sequences works. I actually put 2 proofs into the warm-ups here. This one's slightly fiddly. I'm going to leave it on the screen for you to have a think about. It's the one that I often see explained. I'll do, not with all the algebra, but I'll do something that I've seen before for people talking about this sort of thing. So when you're trying to do a sum like this, I saw someone do this on TikTok this morning. Right, okay. You add together 1 and 100 and you get 101. You add together 2 and 99 and you get 101, and you can keep going. And that gives you a way to do the sum. That says that the sum is 101 times half the number of terms, or something like that. That's one way into doing this sum. Now, I've done that on the board for one particular arithmetic sequence, and of course you can do it for any arithmetic sequence, and of course you can actually explain why that's working, why it's true, and check it out by using algebra. I've tried to give you some pointers of how to do that here. It's a little bit fiddly because you need to write down things like the n+1 minus ith term. The ith term, you need to worry a little bit about whether n is even or n is odd, which of course nobody on TikTok ever tells you to worry about these different cases and to prove it carefully and to check that as you move inwards it keeps adding up to 101. But it does. So something that I'd like to see. Does this method have a name? It's often people talk about Gauss. there's a story about Gauss doing this as a child. I don't think it's invented by Gauss. I don't think the story is true. Yeah, okay, Gauss is typing. Fine, okay, right, Gauss. Yeah, okay. Is that Gauss or am I crazy? Who knows? Right, good. Okay. I'm a little bit worried. When n is even or odd, right? The thing I worry about, not very much, but what if there's like one middle term in this dot 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 in the middle here? What if there's like one term in the middle that doesn't get paired up? Sometimes, not for this thing, but sometimes that can cause you problems in your maths. If everything pairs up, except for one thing that gets left alone, then that's pretty bad. That sounded like a metaphor, but I promise I'm okay. Right, good. Okay. Over here. That's gone over, everybody says. Right, good, okay. I'm not plugging my TikTok. Oh, I could plug my TikTok. I've started the TikTok. I've started a TikTok. It's not going very well. I don't really understand TikTok. I registered my name Maths, James Monroe Maths, on TikTok. I have 3. Oh my goodness, 3 TikToks, which is probably too many. I joined at about the same time as UK Parliament, and they have already left. So I win. I've stayed longer than them. Right, good. Is there an Oxford one? There's a me one. There's a me TikTok. It's not an official Oxford one. Right, cool. This is my favourite proof that the thing works. I can remember the formula for triangle numbers. We've looked at them before. The formula for triangle numbers works like this. If you want to know how big a triangle is, like this right-angled triangle, and this time I really mean that it's right-angled, something you can do is to draw in another copy of the triangle upside down. Let's see, you try this with your equilateral triangles. Then what you've got is a shape commonly known as a rectangle. The side length over here is n, and the side length over here is n plus 1. So the triangle number, the number of blue dots over here, must be half the area of that rectangle, or half the number of dots in that rectangle. Yeah, so it is fine. Sorry, this is an important point. In case this wasn't clear, this is an important point. The middle term is the average of the n numbers, so it's all fine. Even if there's a leftover number in the middle, we're all okay. That's what I wanted you to say for question 10. The formula's cool. There's no controversy here. It's all okay. Odd number of mistakes is a very good joke. Oh. Sometimes somebody does a really good joke in chat, and it's quite tempting for me to just read it out, but that's not how this works. Right, good. Okay. So, favourite method. I was trying to tell you about my favourite method for arithmetic sequence summing. Because I'm quite bad at remembering formulas, but I can remember this picture for triangle numbers. So I've got this is living sort of rent-free in my head, this kind of rectangle picture, to remember how big triangle numbers are. So I don't really know this formula. I mean, it's probably 50-50 that I can write down this formula correctly if I try to, but I can definitely remember this rectangle picture. And if I can remember the rectangle, then I can remember n times n plus 1 over 2, which is that's what this is. So when I was writing those notes, I didn't look it up, I imagined the rectangle. Okay, right, what I want to do is, when you do the sum of the terms in an arithmetic sequence like this, a plus, and then that last one, that irritating last one, a plus n minus 1d. Messed up a plus sign, gonna have another go. A plus n minus 1d. What you're really doing, if you'll let me regroup the terms a little bit, and zoom, regroup the terms a little bit, you've got n copies of a, if I bring all of the a's out, 1, 2, 3, n of them, and you've got d copies of something that goes 1 plus 2 plus 3 plus dot 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 plus n minus 1. I stand a chance of being able to do that manipulation in my head, by the way, to have n copies of a, and then the terms with d's in go 0, 1, 2, 3, up to n minus 1. But I know what this is. This is triangle numbers. I've got to remember that it's it's not the triangle numbers up to n, it's the sum of the numbers up to n minus 1. So I need to remember to write down n minus 1 and n, rather than writing down n and n plus 1. But that's not too bad. And I get this formula. And I think remembering this reason takes me about as long as it would for me to remember the formula. And if I remember the reason, I'm more likely to get it right. So somebody asked earlier, is it important to know proofs? And I think it's important to know proofs for 2 reasons. One, that you know why things are true. And just knowing why things are true important for being a mathematician. But also, being able to derive things gives you an easier way to remember stuff sometimes. It can feel like there's loads of things you have to remember in life. And having the kind of minimal bits to remember something complicated. Yeah, I did just use the phrase rent-free. That is probably a problem. Oh, somebody's found my flashcards. Oh, it's good. The flashcards! I've got the flashcards. Right, okay. We're at the end of the warm-up. We're going to do some math questions. But first I want to plug a resource that I'd forgotten about, even though it's right here. Let me show you. The flashcards. How do I know there's triangle numbers? That's what the triangle numbers do. This is what the picture is, right? 1, 2, 3, 4. This is the picture. I'm reading it right to left, I suppose, but that's what the triangle numbers are. Somebody's already printed the flashcards. I've also found the flashcards. People found the flashcards. I was going to show you them at the start, but I forgot. Right, okay, imagine this is the start. Hi, welcome to the live stream. I'm really excited to show you something I've made for you. I have made you some flashcards. Well, there they are. So they look like this. I've printed them out and stuck them onto some business cards. If you want these, you can get these off the MAT website, or the MAT Live website down there in the bottom corner. The way it works is it's a set of flashcards with facts from the MAT syllabus. So here are some facts that we've just seen from the MAT syllabus. And on the back, it's got the facts. So you might look at the front and you'll think, aha, that's a geometric series, and I know what the sum is, it is that. And there's a term and condition on here as well that I haven't mentioned in this live stream, but hey, there you go. There are 40 of these, and they're designed so that you can print them single-sided and stick them to business cards or trading cards or whatever you've got lying around if you want to. Or if you print them double-sided, then by the magic of double-sided printing, they should all match up after you print them out and cut them up. This was a bit of a pain to work out, so I hope it works. It also gives this quite nice effect, I think, that if you just look at the cards in the document on the website, it's completely mad because they're all next to the wrong ones. Yes, they're not paired up because they print magically double-sided. That was the question in chat, right? Maybe they're just wrong. Where do you buy these? These are free. It's a free download that you can grab from the maths website. So this one's testing like cosine of minus x. You look at it and you think, yeah, that's the same thing as cosine x. It's cosine x. The idea is that you're training the bit of your mind that spots something, recognises it, and thinks, oh yeah, I know that. That's k times kx. And if you don't know it yet, then hey, you just learned a fact. These are free. You can download them from the website and then print them on, I guess, 4 bits of A4 paper, and it should all line up nicely. Or if you print them single-sided, you could stick them to a bit of card or something like that. There's some trigonometry coming up. These are the same content as the MAT syllabus. Yep, same content as MAT syllabus. So we're going to go through these on the live stream. Oh yeah, how did the area work? Oh yeah, you integrate, don't you? That's an integral. Yeah. Okay. You're supposed to find the endpoints first and then integrate. Okay, right. I remember that one for the next time. And we designed them so that the backs have got spots on, so that if you get them mixed up, you can sort them back out again. Good, right, cool. I sort of hope those are useful for revising A-level maths or equivalent. If not, then sorry. Right, okay. I have stuck them onto business cards one by one. I've stuck them onto my own business cards. They're not in order in the PDF. I mean, you cut them up and shuffle them, so they're not in any particular order. Go to if you want to get them signed. Right, good. Do a riffle shuffle. You know I can't riffle shuffle. We found out. So these are partly inspired by the fact that people found the cards 3 weeks ago. People found some cards very interesting on the thing. They match up. Brilliant. Good. I actually got 3 different undergraduates to check. We printed them, and I got 3 different undergraduates to check that I'd matched them up properly. Flip on the long side. That's a good point. Esteban, you're correct. I love it. We can only 20 of you can do this, but 21. Hockenberg, 22. Only 22 of you can take Formula 1 names, but flip on the long side, please. That is something that I should put in there as well. The font is called Computer Modern, and it's the default font in LaTeX, which is also the thing that made this. The original business cards are my business cards. Tutorial on how to print these correctly. Yeah, I should put more instructions on the website, right? The website has got some instructions, but it should say flip on the long side. Good, this is a lovely break to talk about things. Do I know anything about Pat Live YouTube? So Pat are doing a series of live streams. There is such a thing as Pat Live Stream. There's a link on the Matt Live website. I'm learning how to point at it. Down there, Matt Live website. There's a link to the Pat things over there as well. They're doing free live stream things as well. I put a couple of circle theorems on there. Facts about circles is good to know. Good to know facts about circles. Can't find them. They are on the Matt Live website. And then click at the bottom. There's a picture of them that you can click on. Link in chat, maybe somewhere in a minute. Oh yeah, there's also a competition to win the things. Harriet didn't win, sorry Harriet. I did sign the notebook, right, good. Somebody wants them on cram. That's an idea. Should we check them for typos first? Let's check them for typos and then stick them on other places as well. I never really used flashcards as a student, but I've heard that other people find them very useful. So we're doing some flashcards. Has that worked? Oh, that looks like a link. I'm always a little bit careful with links in chat, right? But that looks like it is a link to... Yeah, there we go. Cool, so they don't match up, right? Because they look like this in the file. I sort of find this quite funny. So it's got this over here, and then it says Pythagoras on the right, and that's just nonsense. But it's okay, because when you print it, it matches up with this thing on the back. If you print it double-sided, it's flip on the long side. Right, cool. The CS department might be joining in with ours as well at some point, and they use the mathematician test as well, which is what we're doing here. It's 6 o'clock, and we're going to start doing some maths. I don't really know about cram, so I'm going to go and find out about afterwards. Good. No. Okay. The printing was a nightmare to think about and work out. Let's not talk about the cards anymore. Let's do some math questions. That's why we're here. Is it why we're here? Why are we here? What are we doing? Math questions. Okay. They are revision for AS. Good. Okay. I think we have a link. I'm going to highlight the link. There's the link. Cool. And I will add it to the YouTube description afterwards. It should already be there. It's not there, is it? Good. Here we go. So here's a question from Matt 2016. It's one of the multiple choice questions. Matt's got 10 multiple choice questions at the front, and then you do 4 longer questions. We'll get there in a minute. We're talking about a sequence AN. It's got the first term A1 equals 1, which is popular with 52% of the people watching this live stream. And sorry, everyone else. And the next terms are defined by n plus 1. So that means that the n plus 1th term is L multiplied by the previous one. I'm going to write capital L's throughout because the chances that I can write 1s and L's differently is pretty small. For the multiple choice questions, you can just change all the letters if you want to, I suppose. There's kind of nothing stopping you. If you prefer to write your sequences as X instead of A, then off you go. If you want to renumber everything to start from 0 instead of 1, then up to you, I suppose. Right, good. The flashcards that we've made are just for the math syllabus. If you want other stuff, then I don't know. Let us know. I mean, we made them for the Matt Livestream and for the math syllabus. I enjoyed making them, I suppose. Yeah, people in chat very unhappy about A0. Right, cool. We've got a question on the screen, which is to work out the product of the first 15 terms of this sequence. And I'm going to turn on a poll for this, so that when you've had a go at this question, you can let me know in that poll there what you think the answer is. Question in chat behind the poll is: do you have to invent new maths to do a PhD? And the answer is that most people do. I think it's possible to do a lot of literature review and to bring together other people's ideas in a new and fresh way. But yeah, I think almost everyone does some new maths during a PhD. Good, right. Yeah, no, it wasn't Ella yet. Oh, brilliant. Good, right. That's actually not showing any votes, is it? It's one of those ones where I'm sort of hiding the answers. Can I hide chat? How do I hide polls? Used to be a button for not showing the poll while it was... no, okay, while the poll's going, we can't see chat. Chat's being very funny behind here. which is fair enough. Right, let's have a quick go at this question because people in chat are having a go at it, which is, I think, well, maybe I should ask chat a little bit as well. Chat, what's your approach for having a go at, what's your approach for getting started with this question? I'll do a spoiler here that at the moment 87% of people in chat are correct. A is quite popular as well, but D is 2 question marks for looking very plausible right now. What's your approach? I can't really answer this IB question right now. Yeah, list some terms. That's a good idea. First few terms. I really like that. Yeah, and it's not the hint on the screen. Yeah, good. Oh my goodness, that's amazing. That is just, you've got the level of the level of comedy just right, Randall. Good. Oh my goodness, right, okay. Loads of calculation going on. Okay. There's some sort of arithmetic sequence hiding in here. I like that. In chat, something about arithmetic sequences hiding in here, which is weird because it is a geometric series. This is a geometric sequence. The answer is going to involve, as we go through, doing some arithmetic sequence stuff. Let's see how that works. So A1 is 1, A2 is L, A3 is L squared, A4 is L cubes, and so on up to A. What do I want? The product of the first 15 terms. A15 is L to the 14, being really careful because I've seen the pattern here. Each one has got the power is 1 less than the number in the subscript. Okay, the product of all of those things means multiply them together. And then we could do some laws of indices stuff to say, aha, that's L to the power of 1 plus 2 plus 3 plus 4 plus ... plus 14, I think, which is 14 times 15 over 2. Triangle numbers, again, which is L to the 105. The answer is D. Sorry, I sort of accelerated there at the end when it became more and more obvious there was going to be this thing in chat. Yes, brilliant. So it's sort of weird that the thing in the question is a geometric sequence, but then the, you've put it so well, Anonymous, the laws of indices turn the product to make it more like an addition for what's going on in the exponent of this thing. It's an arithmetic series in the powers, and when you're multiplying things together, it's the sum of the powers that works. Yeah, I will come back to the IB question later if I can. I think it was a good question, but it looks quite complicated. Chat's going super fast right now. Okay, good. We've done a math question. It was worth it. 5 minutes past 6. I'm glad we got that second hour. I thought it was quite good. I quite like this as a math question. Sorry, before we move on. I like the way it's sort of a surprise, different sort of sequence. It's asking for the product, which is not a thing we really know about because we mostly talk about sums. So far for the last hour, we've been talking about sums of sequences. This says product, so you think, oh, I don't really know about products. But then you start working it out, and it turns out, oh, there is a sum after all. That's nice. People in chat go for logarithms. I love a good logarithm. I'm not certain that the logarithm makes it easier here, but I respect the decision to use a logarithm. I think if you know about logarithms, you probably also know about laws of indices. Then maybe the maths that I've written on the screen is slightly easier to do. But yeah, I'm one of the biggest fans of logarithms that I know, so if you're going to go for logarithms, then go for it. It was a bit easy. There's a 1A. The 1A is the first question on the paper. Sometimes that one is a little bit easy. We will find out. The next one we're looking at is a 1G, which is not easy. And this has got 2 sums in it. Remember these sum symbols, we didn't really talk about them. They mean adding things together. We've got a sum here that's going to add together things from k equals 0 up to m minus 1 of these terms. And over here we've got a sum that's going to infinity. Okay, so the sequence xn, where n is bigger than or equal to 0, is defined by x0 is equal to 1. This sequence starts from 0. So now we've made the other 48% of people happy. So that's good. We've extended to 2 hours. So it's going to be 2 hours instead of 1 hour. My goodness. Time for a Greg Sarni indeed. Okay, what are we doing? All the viewers leave because they thought it was 1 hour and they need to go to Greg's. Okay, I just want a quick way to read these things. firstly, this has got lots of centered text and lots of left text. So that's slightly tricky to read. But when you're reading a sum like this, I always read them by going in from the left. So I'm reading the line of maths, like xn is equal to. So I suppose my I is moving like this, and oh, where's the maths gone? Oh, here it is. X subscript n is equal to. And then when I see the big sums, we've got to do some adding. I look down at the thing that we're starting at, and I look up to see where we're going, and then look at to see what we're adding. So that's kind of how I read these sums, to see, aha, we're going to do some adding. Where are we adding from? Where are we going to? And what are we dealing with? And always having that kind of way to pass them in a consistent way means that I find them more consistent. I don't know. Over here, I'm sort of skipping ahead because I'm distracted by this infinity symbol. Love a good infinity symbol. Everyone is now unhappy at least once. So there we go. If this live stream can do anything, it can make every viewer unhappy one time. Exactly one time. No, at least one time. Good, right. What's the question actually wants us to do? Oh yeah, it wants us to work out some terms and add all of them together. Goodness me, so we're adding infinitely many things together. Goodness, that's a lot of work, which is probably why this is G, not A. Right, I think strategy, the hint that I've given you, the MAT questions don't come with hints, the MAT Livestream worksheets do come with hints. The hints in blue are written by me for the worksheet as a way to get into the question. If you try the worksheets before, you can read the hints before we put the question on the screen. Work out a few of the values before thinking about subscript infinity at all. I would definitely, when you see a definition like this, I would definitely go and think about it and work out what's going on with that definition, work out some values before trying to process anything else. Right, okay, James is teaching us to read. Yes, welcome to learning to read. But we're learning, look, we're learning to read complicated Greek symbols with numbers at the top and bottom. Oh, maybe that is too, okay. Right, okay, people are going for answers, so I should give you a poll, right? You want to do the voting, right? This is an extremely democratic live stream. We do all the voting. I want to know how your day was. I want to know how to indent sequences. I want you to do some math problems. I'm going to start working out terms, and hopefully we'll work out what's going on. It goes like this. x0 is 1. x1 is equal to... right, so x1, goodness me. So I can put in n equals 1. As long as I substitute in n equals 1 on both sides. Goodness me, that's a little bit weird, isn't it? That will say x1 is equal to the sum from k equals 0 up to 0. So just 0 then, x k. So I've replaced all the n's with 1s. I made the pen, dear me. Okay, which just means the sum from 0 to 0 is just put in 0 into as value of k. That's 1. That was a lot of talking to explain that x1 was equal to x0. x2 is slightly more interesting. That's the sum from 0 up to 1 of xk, which is x0 plus x1. I've said slightly more interesting, that is 1 plus 1. 1 plus 1 is equal to 2. Welcome to the Oxford MAT Livestream. And then we can keep working out other terms. Each one is the sum of all previous terms. That's a kind of interpretation in words. If you like words and you like reading, that's an interpretation of words of what that sum means. So this thing over here is then 4, and this thing is 8, and now I can see some sort of pattern that these look like they've started being powers of 2. Aha! Which means that the sum we're doing is to add together, spot a pattern, put them together. Oh, the thing they're asking us for, which looks super mad, sum of 1 over these numbers, is just 1 over 1 plus 1 over 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus and so on and so on and so on. So slightly freaky that this is not a geometric sequence because it's got this extra 1 on the front. The extra 1 on the front means it's not a geometric series, but that's fine. We can just ignore the 1, keep that on its own, and have 1 plus something that we've seen before. This series starting here onwards, 1 plus the half plus quarter plus negative 16th is 2. That's something we had before. It's an example of a geometric series. Yeah, proving it is not required. Spotting it is required. So this is a way to reward people for spotting a thing without needing people to prove a thing, which, you know, is fair enough. Which is 3, which is D, again, I think. Let's have a quick look at the poll. How did chat do with this one? Chat, you did very well with this one. Just at 97% on that question. That's brilliant. Even better than with the 1A question. Not enough space. Yeah, well, okay. What I've actually done is I've given myself loads of space, and then I've forgotten to use any of it. I'm a bit... Yeah, I love writing on questions. Writing on the questions is how I want to do the questions. Good. Chat did extremely well at that one. Oh my god, 97%. Couple of questions that I saw going on there. One of them was... I've lost it. Are the incorrect answers deliberately chosen as red herrings or more randomly? And the answer is a bit of both. Some of them are just random sometimes, and some of them are just mistakes that we think people might make, and some of them are just mistakes we think people won't make, but we want to include them anyway. Yeah, spotting without proving is in general bad habits, but it is a skill that you need. You do need to be able to notice things as well as being able to prove things. You need intuition and rigour in life, and that question was maybe more intuition than rigour. Multiple choice, what are we going to do? Here's another sequence question. This one starts at 1 again, so we're continuing our alternating pattern, our sequence, -1 to the n. Oh, that's a really good sequence, by the way. Side note, we'll do a poll on this question in a moment, but a really good sequence. Maybe this is my favourite sequence. It feels a little bit early to have gone for a favourite sequence. There's -1 to the power of n. It's quite helpful because it goes A1 is equal to -1, A2 is equal to 1, A3 is equal to -1, A4 is equal to 1, which is something you get quite with the alternating plus and minus signs. It's just quite helpful to have a neat, tidy way to write. Half my terms have plus signs, half my terms have odd minus signs. I think it's probably some sort of pattern. Yeah, right. Okay. Do I need to spill guacamole on my application to Oxford in order to get through? Goodness me, that's a bit of a deep dive. Good. Right. What's the sum of all those terms? Nobody knows. Well, people do sort of. I shouldn't say nobody knows. This is a geometric sequence which doesn't converge because this has got first term -1, but then common ratio -1, which is not in this. Doesn't match that condition. It doesn't converge. The sequence is very interesting if you try and add them together. Okay. You are not supposed to bring your own paper to MAT. You are supposed to answer your questions in the question booklet. Right, cool. Enough about my favourite sequence. Back to this sequence, which is not my favourite sequence. Everyone agrees. Wait until I hear about I to the n. Complex numbers again. Look, people just love complex numbers in chat. I do. As I was writing the -1 to the n, I was also thinking about I to the n, but we're not doing any complex numbers today. I wanted to do the complex numbers. This is good, isn't it? Working out first few values of this thing is a pretty good way to go. Let's throw the vote on the board. How do I do a vote? Oh my goodness. It's the 5th one I've done today. You'd think I'd have worked out how to do these things. Let's work out some terms. We're given 2 terms this time. We're given the first couple of terms. This happens sometimes. I suppose this one is relating an plus 1 to previous terms an and an minus 1. So we're looking at the relationship there. We can do things like plug in, as long as we're consistent, we can plug in things like n equals, what do I want, n equals 2, I suppose. We're told this is true for n bigger than or equal to 2, so I can plug in 2, and that will tell me that A3 is A2 over A1, which looks like useful information, but I could instead, if I wanted to, plug in n equals 37 or something and get A38 is A37 divided by A36. In words, I suppose it's trying to say that each term is the previous one divided by the one before that. So that gives us a way to write down all these facts. There's facts with this n for every n. It's sort of like being given infinitely many facts. Each individual fact is quite boring. It's like A38 is A37 divided by A36, but we have got a lot of information here, enough in fact for us to work out all of the terms. They go 2, 6, and then the rule is divide the previous term by the one before. But that's in words. I find converting it to words helpful because then it gives my of human brain the chance to actually join in with this. 6 divided by 2 is 3, 3 divided by 6 is 1/2. Now I'm equipped with this kind of, I realised that was a weird thing to say, equipped with a sort of human brain that does human processing on things, which does things better if they're in words. And so sometimes converting this into words that the sort of human language processing part of my brain can do is sometimes a good idea. What is 1/6 divided by 1/2? That's not a question for the language part of my brain. That is a question for the maths part of my brain, which knows tricks for dividing things together. I'm having a wonderful time over here. I've got into a pattern. I've got into a loop. And once I've started looping, I continue looping because I'm doing the same calculations. That's why I speed up as well. A sequence does repeat. And because that sequence is repeating, there's this thing that A1 is 2, 1, 2, 3, 4, 5, 6, A7 is 2, and then every sixth term is also 2 again, which actually means that A2017 is 2. So knowing that A2017, the only relevant thing is that 2017 is 1 more than 2016. I've just seen someone in chat behind the poll mention modular arithmetic, which is not strictly necessary, but hey, good times, talking about things that rotate around. James trying to trick us into thinking he is a human. Yeah. Right, 94% that time. Pretty good. Well done, chat. No, not more than pretty good. Really good. Well done, chat. Equipment in the map seems like an important question. You can bring, oh gosh, off the top of my head, protractor, compasses, pens and pencils, an eraser, highlighters, but you cannot bring a calculator or a computer or a microwave or anything else that can do calculations. Okay, is there a theme like the factorization of 2022? I don't think any past math paper has ever had a theme. Right, okay. We're not seeing these yet. So if you're not seeing these yet, then it's partly because I'm going quite fast. When I'm actually doing maths, I'm doing the maths quite fast. Don't be concerned. What you've identified is that you would like to learn about sequences and series before trying other math questions on this topic, which is a good thing to have identified today. They're doing some other stuff. Someone says, James, you need to reveal the poll results before you tell us the answer, as the answer can be changed. That strikes me as a very important... Okay, the game is up. Right, good. Do Alice & Co. return for 2022? That is, I think I'm not allowed to say. Right, probably safest if I just don't say anything about next year's math paper. Cool, those were some short questions. You did 10 of those, probably not all about sequences and series. And yes, that the answer was D in all 3 of those. So that's a sequence, I suppose, with first term D and common ratio 1. There you go. Right, good. The real sequence was the answers we made along the way. Here's a long question. These are extremely difficult. Compared to, if you just learnt sequences and series an hour ago, then these questions, I think, are really difficult. These are not the standard sort of questions that you would do in school with sequences and series. They are supposed to be hard. I'm trying to be quite cheerful and go through them, and people in chat seem to be able to do the questions as well. But these questions are really tough. They have to be really tough because the Oxford Mathematicians Test is for people applying to Oxford to do mathematics. Those people are pretty good at maths, and we need to be able to shortlist for interviews based on how well people do at questions like this, but not these ones. How do I know when to give up on a question in the mat and move on? I think people should give up more frequently than they do. If you're not having ideas, if you're not thinking of new things, I would switch question. But I have quite a short attention span. Can you tell? I have quite a short attention span, so I'm always changing around between things. Right, good. Okay, that can stay. Right, the microwave. Yeah, I didn't say washing machine. Someone's claimed Lando Norris in chat. That's gone. Good. Every exercise in math. Right, so the short questions are worth 4 marks each. So far we have gained 12 marks. The long questions are worth 15 marks. But those are the only 2 numbers that a question might be worth. I'm kind of concerned because I'm finding these easy. Well, you know, sequences and series are, there's not actually that much you need to know. But hey, right, good. Okay, here we go. We've got a sum Sn, it's divided by 2 plus 8 plus 24 plus, and so on, n times 2 to the n. And the long questions have these separate parts where we're going to do different things with this sum. This sum here is not an arithmetic progression or series, and it's also not a geometric progression either. It is neither of the things that we know about. So that's pretty bad. It means that if it were one of those things, then we would just write down a formula and we would be like, I know how to do this, off we go, we're done, we're good. But unfortunately, we're going to spend the rest of this question working out how that works. Long questions are 15 marks, definitely. Are the marks equally spread? No, there's some parts are worth more marks than others. We don't print how much each part is worth on the question paper, but there is behind the scenes. We know how many marks each part is worth. It's worth having a look. Multiple choice, 4 marks each on the 4 marks each for the 10 questions you do. This is also on the front of the MAT paper. If you look at a past paper, we'll get to some past papers, but if you look at a past paper or just look at the MAT website, then there are other facts about how that works. It's marked by graduate students, and the graduate students follow a mark scheme that I write. Good times. Kimi Räikkönen, so we can have more than 20 people if we're having people who are not currently in Formula 1 as well. Would I suggest doing both MAT and STEP? I mean, STEP's not used for Oxford, so if you're applying for Oxford, then you don't need to do STEP. I think you can do it for fun. If you're not applying to Oxford, then maybe you don't need to do the MAT. You probably don't need to do both of these tests. STEP's used by Cambridge. Isn't it a geometric series? Yeah, it kind of looks almost like one, right? But there's no common ratio. This gets multiplied by 4, and then it gets multiplied by 3 to get from 8 to 24, which is different. Right? It's really small on the screen there, isn't it? Next week I'm going to make the text on screen bigger. I didn't realise I could zoom in. I'm limited on how much I can zoom in. Burrito price going up. It's pretty sad. But we've got competition because we've got different places that sell them, so it's going to be all right. What is this even called? I don't think this one's got a name. We're going to find out more facts about it, but we're not going to find out its name. Oxford or Cambridge, says somebody in the live chat of an Oxford live stream organised by Oxford in Oxford. Ask me, Oxford or Cambridge? What is going on? Good, right. Which is harder in my opinion? STEP. STEP is harder than that, and it's not close. But STEP is taken at the end of sixth form, and MAT is taken in the middle. Oh yeah, I did go to Cambridge. Yeah, that is a lot of sass for a Cambridge graduate. Right, cool. 3 times. Good. Right. Okay. Here's how this long question. Enough about me. Here's the long question. It works like this. There was a warm-up thing where we had those proving that 2 sequences were equal to each other. One of them had some letters in, and one of them we knew the numbers. We're going to do that again. We're going to match up some formula here for what the sequence is in terms of n related to this other definition we know. We're actually going to take a couple of parts of this question, working through the different parts of this question in order to do that. So what I'm going to do is try to set, I'm going to follow the instruction I've been given, I suppose. So I'm going to set n equals 1, 2, and 3 to pair things together. I've got to be quite careful to actually get the right value for Sn. Technically, at this stage, we know all the values of Sn. I mean, we could go and work them out, right? We know what S37 is. S37 just means, well, you take the first 37 terms and add them together like this. I don't want to do that, but we do technically know all the values of Sn, which is a bit weird to think about, right? But hey, in particular, we know that S1 is just 2, because that would be the sum if you go, but stop when you get 1 times 2 to the 1. That was the first term, so stop immediately after that first term. S2 means start the sum and keep adding up, keep going until you get to 2 times 2 squared, or that means 8. So I should keep going until I get to 8. And S3 means start the sum and keep going until you get to 3 times 2 to the 3, which is that one. It means do 3 terms of the series of the adding, right? Which is 34. So I've got these values of S. I'm trying to say I could work out more values, but I don't really want to. And the question has told me to set n equal 1, 2, and 3 to work out these things. So on the other hand, I'm trying to make sure that Sn is equal to f of n. So what do I want to do? I want to plug in n equals 1, 2, and 3 into that expression as well, which I could do, I suppose. I can't really say that I know f of 1, f of 2 and f of 3 in the same way because they involve these numbers a to the a, b and c. But I suppose I can write down these equations. My equations are a little bit messy down here, but hopefully if you're playing along at home then you've got some cleaner version of this. Good. Okay. How do I mark my own 15 markers? Yeah, it's really tough. The mark schemes on the MAT website give the breakdown for how many marks each part is worth. So if you go to the MAT website, the table of past papers has got the marks in there as well. Do I live in the Andrew Wiles building? No, but I had to think about it. Is Oxford University racist? No, I think not institutionally, but could definitely do some things better. Yeah, there's a sort of theme of induction going on in part 3. You don't need to know about induction, so the question kind of holds your hand to do induction. It's not quite that many times I've done this question. I did this question a few times. We're ready to do this question. I've got some equations. Yeah, okay, so we're doing part 1. We've got goodness knows how many marks we're doing part 1. The marking for this would be, I suppose, probably, so far we've got maybe 1 or 2 marks, I want to say, for writing down the equations, which is no method, just going for it. Oh, I haven't written down the right-hand side of my equations. That's very rude, isn't it? Because I've forgotten to tell you that these things are supposed to be equal. This is supposed to be equal to S1. F2 is supposed to be equal to S2. Gosh, it's hard to talk and write at the same time. And f of 3 is supposed to be equal to s of 3, which is 34. Right, good. Phew. So I've got some equations. Part 2 is not very fun. It says to solve. I mean, it's the sort of thing I could technically do by just rearranging the equations, right? So you could do the difference between the first 2 equations, the difference between the second and third, and that would get rid of the c's. Solving systems of simultaneous equations is something we're technically supposed to be able to do, I suppose, and then go and rearrange. I'm going to do that now while talking at the same time. There's the thing about having 2 hours. I can actually do this question. Last year, we put the question on the board and it was just, well, we've run out of time now. So we're actually going to do that. Yes, I do teach at Oxford. I teach applied mathematics. I do tutorials for New College at the moment, which is good. Whoa, what have I done? Sub in N, not A. People in the chat are very keen on matrices suddenly. Suddenly 3 people. 3 of you out there all shouted matrices at me at exactly the same time. Which I sometimes like to imagine that this is happening in person. I mean, we're doing some things back in person again, and I kind of like to imagine I'm presenting this question to a room of people, and 3 people in the audience immediately shout at the same time, matrices. Matrices are not on the MAT syllabus. You don't need to know what a matrix is. We're going to cancel some C's. Well, calculate. We're going to cancel some C's because we're going to solve this using methods that everybody knows if they're doing A-level or equivalent by finding the differences between some equations 1, 2 and 3. Okay, so I'm going to try and do that while talking at the same time. I haven't met Marcus Sotoy that many times around the building, but yeah, Marcus Sotoy is one of our mathematicians here. 24a minus 8a is 16a. I thought this would be more impressive than it is because I can't actually do that as fast as I thought I could. Those are equations 4 and 5. So I was laughing because somebody shouted eigenvectors in chat, which is another matrix word that you either know that word or you don't. People who know about matrices, there's a very clever thing to shout, but yeah, you've got to go and invert your 3x3 matrix round about now. Whereas I am happily doing differences between equations. I'm not going to do equation 5 minus equation 4, I think, because I want to get rid of these b's. Oh, do I want to do it like that? No, I need to get rid of the b's, so I need to do 3 times that one minus 4 times that one. People will tell me in chat if I get this wrong. 4b take away 2b. Yeah, they've told me they've got it wrong. I thought it was 8b minus 4b. Yeah, because I started reading the wrong lines. That is how we do. 8a minus 2a. Oh no, 3, 4, 8. Now I've got double confused. 4b minus 2b. It's 2b up here. 2b, found it. 2b or 3b? That is the question. And the answer is 2b. That would have been funnier if I said not to be. Anyway. Yeah, 2 minus 1 is wrong. Thank you. Good. Cheers. Got it. Good. Is it 24 in equation 3? No, and right, yeah, common misconception. It's 34 in equation 3, right? Because it's 2 plus 8 plus 24. S3 is not the third term of this thing. It is the sum. Keep adding until you get to the sum S3. The sum S3 means add together. Keep adding until you get up. So it's 34, not 24. And now you're going to tell me that, no, you mean I've done some subtraction wrong. How are we doing today? We're doing all right today. We're doing all right. At a solid 4 stars, I think. Solid 4 stars. Right, 16A minus 12A. Why did I think this was a good idea? 16A take away 2 lots of 6A is 4A, and I've cancelled the B's off correctly. Am I going to get to the same answer as everyone else after quite a lot of work? Plug it back in. A is 2. B is... I get 12 here, I need to take off 4, so I'm going to subtract 2. Lots of 2. C at the end there. A plus B is 0 in mine, so C is 2 at the end. Reading back again. Using a method that's not on the mark scheme is absolutely fine. You can still get marks, unless you're told to do something. So here we were told by setting n equals 1, 2, and 3, so we've got to do it. But otherwise, using a method that's not on mark scheme, absolutely fine. I reckon the mark scheme here probably solves the equations with a method like I've done, with plugging things into each other. But if you know about matrices and you do it with matrices, totally fine. S-Ben Ocon, not a big fan of matrices. Oh, I saw Lando as well, earlier as well. Just shout out to whoever picked Lando. Equation 4 is a bit wrong. I think you're a little bit behind me in chat now, or I'm behind you or something. That is in fact what I got, congrats. Thank you. For part 3. Right, okay, moving on. Yeah, somebody's moving on to part 3 already. Okay, good. We've now got down to, pause before we do part 3, sorry. This is important for our understanding. Understanding gets us marks. It's not obvious how understanding could get you marks, right? Because understanding is something that happens in your head, and you don't get marked for what you're thinking. But understanding helps you to be able to do the other parts of the questions. So let's take a moment here to understand what we've done. We've checked that for n is 1, 2, and 3, this thing in the box up here is true. That Sn, this sum, that we didn't really know what this sum was equal to 2n minus 2, because I now know a, b, and c. 2n minus 2 times 2 to the n plus 2. That's kind of cool. I mean, we've only shown really that it's true for 1, 2, and 3. Spoilers, it's going to turn out to be true for all n. But it's kind of cool that a hot minute ago we didn't know anything about what this sum was, and now we're getting towards, I think, having some equation for what that sum is. I'm saying this now because we're going to go do some other stuff. And at the bottom of this question, where we're asked to do a sum of these terms sk, that absolutely hinges on whether or not we've clocked that we now know sk. We know a nice formula for sk. We haven't quite got there yet, but looking ahead at what's coming in this question is important to understand what sk really is. So understand, we came in, it was a mystery, we've now done some work, and found out something about sk. That was a shout out. Right, okay. People in chat seem to be slightly better than me at rearranging equations, which is nice to know. You are the experts, you are learning this at the moment maybe, and good at answering solving simultaneous equations. Right, good. I have this penalty of also talking at the same time and being on a live stream at the same time and trying to moderate chat at the same time. I should really get someone to do that. Right, good. Let's think about part 3. It's going well. We've got an expression. We know it's true for 1, 2, and 3. We're going to say, using these values, show that if... So this is a show that question, by the way. I'm underlining too many things. Let's underline show that. Show that question is where you're asked to prove something or demonstrate or explain why something's true. Show that if sk is equal to f of k for some k bigger than 1, so some number k, just some example of a k, then it follows that sk plus 1 is equal to f of k plus 1. Okay, so this is going to be really good news in a minute. This is how proof by induction works. Proof by induction is not on the mat. Let's come and do part 3 down here. So we've been told that if, let's write that out, if sk is equal to f of k, so that would mean that sk, which is 2 plus 8 plus ... plus k times 2 to the k, is equal to, that would be 2k minus 2, 2 to the k plus 2. All I've done so far is I've plugged in k's into the things we already knew. We knew what sk was. It was that sum up to k 2 to the k. I've replaced the n's with k's. And we know what the function f is, because we now know a, b, and c. 2k minus 2, 2 to the k plus 2. Okay, right, we are asked about now. Now, sk plus 1 is equal to, I'm again just writing down what I know. If in doubt, writing down what you know is a good idea. Writing down true facts is sometimes more helpful than you think it's going to be. So I've got sk plus 1, and I want to say something clever about it, or just say anything intelligent about this. Oh, did someone say they were going? Okay. Somebody asked me about applied maths ages ago. Whoops. Did not answer that question. Got distracted. Cool. Anyway, something you can spot is that in sk plus 1, there is some relationship. I wrote a hint about this, which is not on the screen at the moment, but if you download the worksheets before the session, you get the hints. That sk plus 1 is basically the same as sk. It's not the same, but it involves a lot of the same terms. It's got 2 plus 8 plus 24 plus, and then so on. And it's even got a k2 to the k in it. But it's also got this last term on here, this new extra term at the end, k plus 1 times 2 to the k plus 1. That's pretty good. While I was talking, written down sk for the sum of those first k terms, because that's just what sk is. So really, I suppose what I've done is I've written something about how sk plus 1 depends on sk, and the number k as well. It's a little bit complicated to think about strictly what sort of recurrence relation this is, but brilliantly this has identified for us the relationship between sk plus 1 and sk. See, here is if I say brilliantly for some maths that I just wrote down. Can we download this or just do it through YouTube? I mean, it's broadcast on YouTube. I don't think YouTube gives you the opportunity to download it, but I think there might be external websites that download YouTube videos. Yeah, good, okay. This is sk plus 1 because I know what Sn is. Sn means the sum 2 plus 8 plus 24 plus. Keep going and stop when you get to n2 to the n, please. Which means that if I've got k plus 1 down here, well, I just keep going until I get to k plus 1, 2 to the k plus 1. That's just what Sn is. The very first thing they told us way up here was, oh yeah, that's what you do. You start 2, 8, 24, you keep going until you get to n, 2 to the n. What's n? Oh, n's the thing in the subscript. Being able to switch around the subscripts like this is quite important. Being able to just change what's down there and reinterpret it, so that if I had sort of like s epsilon is 2 plus 8 plus ... plus epsilon 2 to the epsilon. I mean, kind of technically true, I suppose. Not very interesting because there's no other epsilons in this question, but being able to sort of just switch the letters around because it's true for all of them, so you'll be all right. Good. Okay. Yeah. So someone says it's proof by induction without the base case. Yeah, and then a person has replied, we did the base case in the previous parts. We actually did. Yeah. Rebel here as well says we did the base case. We did 3 base cases. That's more than was strictly speaking necessary. What am I doing? I'm doing algebra. Again, I feel like I'm doing a lot of algebra today, but that's okay. There's a stream coming up later, all about algebra, which that we'll get there when we get there, I suppose. But my word, right? Okay, so this looks pretty good because I can see that I've got terms that look a bit like what I'm going for. I want this to turn out to be, I suppose, 2k plus 1, 2 times k plus 1 minus 2, which is just 2 times k. So yeah, okay, I'm going to try and rearrange this. I'm going to try and group some terms together. The expression that I want this thing to turn into f of k plus 1, which involves 2 to the k plus 1. I'm pretty happy about this 2 to the k plus 1 over here. I want a 2 to the k plus 1 over here as well. So I'm actually going to write this as k minus 1 times 2 to the k plus 1. Keep that 2 around. Oh, I really hope this is true because it's looking quite nice actually. I've got k minus 1 here and I've got k plus 1, and now they're both multiplied by 2 to the k plus 1, so I'm going to bring those together. I'm going to do it. Okay, 2 to the k plus 1 plus 2. Okay, it looks pretty simple. Also, I know that f of k plus 1, I'm really hoping this turns out to be the same thing. So the function f is 2 times the thing minus 2, multiply all of that by 2 to the thing you're thinking of, add 2 on the end, which I think is equal to that. So I'm done, I think. F of k plus 1 is equal to s of k plus 1. Amazing. Epsilon, not epsilon. Oh, right. Epsilon, not epsilon. That's quite a hard thing to pass. Wingardium Leviosa. Where did you get this worksheet? Where do I get this worksheet from? There's a website at the bottom of the screen. Link in the YouTube description, and if you search for Oxford MAT Livestream, hopefully you can find the homepage, which has got not just this worksheet, but also the next 9 worksheets. So you can download all 10 of them and the solutions, except one of them, which is broken. We are going to fix it. I would always start without a time limit, and then work up towards the time limit. I think thinking about the time limit is not helpful until you get good at doing the questions. Bold of you to assume that I know IPA. Yeah, so it's quite hard to follow the algebra when someone's doing it on the screen, right? It's kind of all I've got, right? To do this live stream like this, to put algebra on the screen for you to look at. It's probably healthy for you. If this didn't make sense, it's probably healthy for you to grab a bit of paper, forget you've seen it, and just try and do it yourself. You've seen kind of the structure of how it might work, that it might turn out to be equal to f of k plus 1. But actually doing the algebra yourself is probably quite good. I'm bringing out that too. I will try and explain, but you should maybe just grab a pencil or something. I'm trying to add these terms together. I'm trying to add these terms together quite quickly. Anyway, maybe that wasn't very good. Oh, link to the worksheet. Thank you very much. A good average score is about 70. If you want to see other average statistics, you can check the MAT website. Link. Well, if you take LIVE off the end of the URL, you get to the MAT homepage. The live stream is not going anywhere. You can watch it again afterwards. You can watch it again later. Same URL. It'll just be here. You can also rewind it while we're going live, or pause it and come back. Just remarkable technology from my point of view anyway. I'm old. Right, good. The worksheets are almost exactly the same as last year's. Can we do the IB question? Oh, I really want to do these sums. I want to do these sums just because I've got 15 minutes. Look, I've got 15 minutes. I can finish this and then do the IB question. It's going to be really good. You're about one question ahead because you started early. SV, were you not here last year? I feel like you were here last year. Were you not here last year? Anyway. Winchester crew are checking in. You've waited an hour and 3/4 before doing your shout out to the West. It was a little bit bold to go an hour and 3/4 in. Who's here? Right, good. I like it anyway. There we go. Winchester, not Westminster. Did I say Winchester? Westminster? Winchester. Right, cool. Lando is mocking me for technology. We only did warm-ups last year. SV was here, but we only did the warm-ups because we never did the full questions. I'm going to talk about IV, which I almost never talk about. I talk about this question quite often because I've decided that it's one of the ones that I talk about everywhere. I almost never talk about part 4 on this. Jump cut to previous video of James talking about it, part 4. We're gonna have a go at it. The trick here, we've been told, by the way, we can now assume that Fn is equal to Sn. Brilliant stuff. The trick here is to spot in Tn. How can we use the facts that we know about Sn? So we now know Sn. Brilliant, amazing. We now know that 2 plus 8 plus ... plus n times 2 to the n. We now know that that's equal to 2n minus 2 times 2 to the n plus 2. Brilliant fact. Hope we get to use it somewhere. Good. Is there an Sn in there? And someone, anonymous person in chat here, it's often the anonymous people with the takes here Sn, but they also say minus Sn is in there somewhere, and they're correct. There's a secret hidden copy of negative Sn hiding in that sum for Tn. I don't know about your first attempt at that practice. I think could be anything. Could be anything. I'm not even sure I would do whole papers to start off with, which is why I've made these worksheets to look like this. Okay, have people spotted this copy of minus Sn that's hiding inside the Tn's? I'll try and point at it. In here, there's a negative 1 times 2. Over here, there's a negative 2 times 4. Over here, there's negative 3 times 8. Ha! Those are 2, 8, 24, and so on. So you can use that. That basically kills the question, because now you've spotted that this is some stuff, and it turns out to be n plus 2n plus 4n. The n terms, you can pull all of those out together, plus 8n plus, oh gosh, how many do I want at the end? Slightly tricky question. I think I want 2 to the n minus 1, but I'm not certain. Possibly that many. Minus Sn. Minus n minus 1. Vaguely confident. N minus 1. Getting less confident with time. Welcome to questions about maths. Minus Sn because it's being subtracted off. That Sn would include at the end there a minus n 2 to the n. Is it s minus n minus 1? A little bit worried about this. N's and n minus 1's. What am I actually subtracting? Maybe I should work it out properly rather than just try and guess. What is that? That's I've really confused myself, which happens more than it should. N is equal to n minus 1. So it's 2 to the n minus 1. N minus 1. So that's minus n minus 1. It is Sn minus 1. Good, right, do all the expanding. Good. And then plug in n minus 1 for the sum from before. And we're good. And we've got a geometric thing. We are doing about 6 things at once, but that is just how I like it. Just how I like it. Physics A level. Don't do it, but now I find it interesting. These days there is so much cool stuff on the internet, partly to help people revise A level physics, and partly just people talking about cool physics stuff, which to be honest is probably more fun. So actually going out and doing other stuff. There's just heaps of content lying around out there. Some of it's really good. I'm a big fan of Steve Mould. I think Steve Mould's very, very good. So there you go. Free shout out from us. So he doesn't need it. Not sponsored. Am I doing interviews? I don't know. Good. We'll do the IB question in a second, I promise. We've spotted the mystery of Tn. We're now going to do Un. The mystery of Un is that we've got 1 over 2, 2 over 4, 3 over 8. So I've got these numbers on the top, they look like n's. That's quite encouraging. I've got 2 to the n's on the bottom. What's going on here? What's the relationship between, I guess, Un and something we've seen before? Is it possible to go from the Math and Philosophy course to MMath Phys? I think the answer is no, because you've missed lots of applied mathematics. Applied mathematics is maths that's, I guess, applicable to the real world. So maybe using differential equations to understand fluid dynamics might be one example of applied mathematics. How do you stand out in an online interview? By doing the maths questions that we're going to ask you. At interview, we ask maths questions. If you can do the maths questions, that will help you stand out. Aha! Yeah, Oscar's pretty close. Something to do with Sn and n squared. Oh, I see what you're doing. Yeah, I see what you're doing, Oscar. Because you've got like you've spotted that last term there. It's like n over 2 to the n, which is related to the last term in Sn, which was n 2 to the n. So you put n squared on the top, you put that on the bottom. Doesn't quite work for the other terms, but you're very close. There is something you can do to just like cheekily do some division from things before. I like that you went for that. Interviews normally 20 to 30 minutes. We're going to talk about interviews later on. We'll do a bonus live stream in a couple of months on interviews. If you want to find that, you can you can look at last year's one because it might be quite similar this year. So if you want to get ahead with the live stream, something you can do is to go back to last year's live stream and go ahead a couple of weeks and watch me saying this 1 year ago, but not from my office. Haha, I'm in the office. Oxford interviews are definitely online this year. Right, cool. We've got about 5 minutes, and we're doing pretty well. UN, it turns out, is I think it's a little bit sneaky. If I list the terms backwards, do you get it? If I list the terms backwards, let's find out. I'm going to list the terms backwards. I'm not sure how much I like this in a test, really, but. Sometimes flipping it around, reverse it, is the right way to go. I definitely didn't leave myself enough space to do this, did I? In the test, you get blank paper in the booklet next to the question. You don't have to do what I'm doing and write on top of the question. I am trying to show you the question and the solution at the same time on quite a small screen, which is pretty silly. There is a reason, it says number file in chat, why they got you to do TN first, and that is because, as Rabble says, this is precisely Tn divided by 2 to the n. Drawing lots of these safety fences to keep my different bits of maths apart. Not the flip it and reverse it again. But I love that joke. That joke's great. It's a reference to a song that's older than everybody watching. You've got to let me do the references to songs that are older than people watching. Right, good. We had several disastrous attempts to do that pun or joke. How does the marking handle reading errors? Asks Alfie. There's a little bit of error carried forwards. Sometimes, depending on the question. Wherever you make a mistake, then you can still do a version of the question, and if you're still doing the right sort of method, then it's possible to pick up method marks. Sometimes. Can you do maths on its own and do postgraduate study in maths and physics or maths and theoretical physics? Yes. If you do a maths degree at Oxford, you can, if you do the right sort of stuff, you might be able to do maths and theoretical physics as a 4th year, which is a 4th year course we do. Give it a search if you're interested, maths and theoretical physics as a 4th year course, and then do, postgraduate. More stuff after that if you want to. We're going to finish up today by finding this sum and answering that IB question that I've mentioned a few times. 6 things going on at once, that's just how we do. We're going to add together, for our last trick here, we're going to add together the terms SK. We have to do this because it's in the thumbnail, and this is not a clickbait kind of channel. We actually do the maths problems that we put in the thumbnail. Right, so what we've got now is we've got down to Sn. We know that it's 2n minus 2 times 2 to the n plus 2. And we've been asked to add together, we want the sum of those things from k equals 1 up to n. Okay, so we want to do that particular sum. We've kind of already done a sum to get to this point, but now we're going to do one more. This looks impossibly difficult until you start plugging things in and going for it. From k equals 1 up to n, I need to put a k in here, don't I, if I'm summing over k's? Okay, so my sum goes from k is 1 all the way up to n. And actually a good thing to do here is to, I'll put more brackets in, is to expand out that bracket that I just drew. And think about this as kind of 3 separate terms. So there's like 2k times 2 to the k. There's a factor here that's like minus, going to subtract a bunch of terms. 2 times 2 to the k, from k is 1 to n. And then there's this term on the end which is like 2 all the time. Every term in this sum is 2, 2, 2. So that's just like 2 times n at the end. I can do that sum. There's n terms in the sum, big sum overall, and at the end they've all got plus 2 at the end. So okay, we'll get n copies of 2, I guess. The second sum here, that's geometric. That's geometric series. It's the sort that we saw in the warm-up problems, and it's the sort with that common. It's got a first term and a common ratio. So that makes me happy to see that. We can do that sort of sum. Maybe not that happy. Hang on. Makes me approximately that happy. Yeah, that sounds right. This one over here looks much harder, but if I bring the 2 out, then maybe you can spot that this thing we're being asked about, so we're now kind of just doing pure algebra, we've forgotten what everything means, we're just robotically manipulating symbols, but then you've got to kick in the recognition part of your brain that says, hang on a minute, I know what this is. This says the sum when you plug in 1, 2, 3 up to n, that says you do 2 plus 8 plus 24 plus keep going until you get to n times 2 to the n. That is Sn. Right from the start of the question. So what I end up with for my final sort of answer down here, I guess maybe not final answer, but hey, is, am I going to do the geometric series? No, I'm too lazy to do the geometric series right now. Exercise for the reader. Oh, that's really lazy. I should do the geometric series. I'm going to do the geometric series while talking about it. We get down to some sort of final answer where we recognise part of the sum in terms of Sn. We know part of the sum in terms of a geometric series, and the other part of the sum was really, really easy to do. So I think we end up with something like this. Don't forget to multiply 2 by all of these terms, take away, and then that geometric series, it's powers of 2 starting at 4 and going up to 2 to the n plus 1. So I need to do 2 to the n plus 2 minus 2 to the 3, I think, divided by 2 minus 1. Oh, don't tell me that's wrong. Good, cool. Minus 8 on the end, plus a 4, something like that. Rearrange. Simplify it if you like. It turns out to be approximately 2 to the n, more or less, up to some factors of 2 or 4 or something, times n, which is about the same size as Sn, which is maybe a little bit surprising. You've got this sum of adding together all of them and it ends up being about the same size as the last one. But that's sort of how geometric series work as well, that you add together all of these terms and you end up with about the biggest one. Does that simplify much further? Oh no, hang on, where are we going? can you do a PhD with just an honours degree at Oxford? Where you do an honours degree first, and then you usually do a master's, and then do a PhD after that. That's normally the series. That was not clickbait because we did the maths question. Look. Hang on. There we go. There we go. Let's fill the thumbnail. Right, good. I'm going to be so underwhelmed with the IB question. It's 7 o'clock. But I'm going to look up the IB question. I'm not going to be underwhelmed. I'm looking forward to the IB question. What have I done? What is that? Oh my goodness. Okay, right. There are several questions about IB. Do IB mathematicians generally have extra maths, such as a 7th subject in higher level further maths? No, not normally. Sometimes people get to do higher level further maths, but not all the time. And there's another one about whether is 75 on the MAT doing IB, much less maths than absolutely as proportion of time. Is that more impressive than getting 75 on the MAT and doing A-level maths and further maths? I think I know what you mean, that the people who are doing maths and further maths, they're doing loads of maths, so maybe they should do better on the MAT. Unfortunately, the Oxford policy is that I'm afraid IB is considered good preparation for maths at Oxford. I'm afraid that. Good news, right? That if you're doing IB, then we think that's good preparation for maths at Oxford, which means that unfortunately we expect you to do just as well as the people doing A-level maths and further maths. To back that up, there's no further maths on the MAT. The people who are doing maths and further maths, okay, maybe they're spending lots of time thinking about maths, but so are you, because you just watched 2 hours of maths live stream from Oxford when you could have been doing anything else. So that balances out. That they're doing further maths, you're doing extra stuff, like seeing MAT questions in August. I'm sort of joking, but also not joking, that we think IB is fine. And I sort of think this question comes from a point of being a bit worried about the IB, and maybe it's helpful for me to look directly into the camera and say, we're not worried about IB. I wish you all the best. Right, good. Did I do it? Was that the IB question? The geometric series part. I did do it eventually. I did it quite badly, but it's the sort of thing that could be a warm-up question. So if you would like to see this, it is more or less exactly the same thing as warm-up question over here. I also skipped this one. I've got a type of question that I skip. Ones with a weird starting term and an end term, and then you've got to think carefully about the factors of n. Skipped it over here, and I skipped it in the long question as well. I think I got the right answer. We will see. Have a quick look at my notes. This is actually the biggest difference this year. And this will sound like a joke, but it's really, really not a joke, is that this year I've actually brought notes along with me. I'm out by 1. This says that I'm out by 1. If I missed a factor of 2 somewhere? Oh no, this thing says I'm out by 1. But in the wrong direction. No. Why am I out by 1? Oh no. It's not minus 2 to the 3, it's minus 2 to the 1. Why is that true? Because I didn't want to subtract 8 off the start, I wanted to subtract 2 to the 1. I wanted to subtract the first 3, not the first. Right, take the thumbnail again. Right, there we go, good. I did it wrong, that's why you wanted it again. IB stands for International Baccalaureate. It's a different sort of qualification that is not the one that you've got. Lando Norris is doing French back. Chat just crashed on me, but it came back again. That was the IB question, and it's important because some people are doing the IB. That's like their qualification that they're spending two years studying. We take a lot of international qualifications. We've got a page, if you search for Oxford International Qualifications, goodness knows if it comes up, but there is a page on the Oxford website with lots of advice about different international questions. If you're doing French back, or if you're doing Australian qualifications, or if you're doing US qualifications, or if you're doing Indian qualifications, or if you're doing other stuff, there's hundreds on that website. That is advice out there. Good, okay. Advice about shortlisting, I think we can do another time, or we can do in another place. Shortlisting is not just about the maths, but the maths is pretty fun. It's got some maths questions on it. We like maths. If you download the worksheet and the solutions, then you also get a couple of bonus bits of content. This is for the people who wanted off-syllabus stuff. You also get some extension material where I've laid out a different way of doing the sum from that long MAT question. The bonus material is sort of just there because I wanted to give it to you, of a different way to do that different way to do the sum, not the way in the question. So it's not a good idea for the question, but hey, it's a different way to approach that sum that you might be able to use, I don't know, somewhere else in your life. And also I threw in a little bit of calculus. This is definitely not maths. I've tried to label it as not maths. The extension at the end is not maths. I think I put a disclaimer at the top here. It's not maths. But if you want to find that, that is on the website down there. To download the question sheet. The solutions document is also up. That comes with some reflection tips at the end for ideas that you might have after trying these questions, trying the solutions. Thanks for watching. If you're here next week, then we're going to talk about, oh gosh, I should not have started that sentence without thinking about what's next. Trigonometry next week. So we're going to talk about some trigonometry questions. Same format again. If you want to get ahead, the worksheet for that one is on the website, as well as the solutions. But you are welcome to just turn up and join in live, or just sort of hang out over here. Other resources, there are other recommendations on the MAT page. Briefly, I really like this STEP support program, and I really like the Enrich website. City and Guilds maths qualifications, I don't know off the top of my head. Is that the core maths one? I'll wait for you to tell me whether that's core maths. I think I know that that's core maths, which we don't count as equivalent to A-level mathematics. And we don't use UCAS points, so it's also not good on there. I'm going to answer questions just for a minute. I've got to go home at some point. Thank you very much for hanging out. It's been lovely to have people here all the way through. People's Day, beyond 5 stars, hooray! You do need to unlock the Canvas page, you're right, thank you for the reminder. I do need to unlock it so that you can actually access the interactive. This explains why nobody's accessed it. I did wonder. Right, cool, we're wrapping up. Nice to have you if you're the first time here. In future, Slido, I will try and find students to moderate Slido. Right, good times. I think I'm going to wrap up. Advice on City and Guilds maths qualifications, probably on the UK Quals bit of the website somewhere. They will be okay. Goodness me. Right, good. Yeah, okay. I'm going to show you the cards one more time. Just to mention the cards once more. Look, cards. Do you want these? You can have these. These are free. You can't have the business cards. The business card element is not free. Well, they're sort of free if you... No, that's not the thing. I'm not selling the business cards. Gosh, what a terrible advert. For a free resource. I'm trying to advertise a free thing and I can't even do that right. There's things on here about binomial choices that I think people get quite worried about because it appeared on the MAT syllabus recently, and there's this sort of thing about choosing things and numbers of combinations. All of that, which we will cover in the MAT livestream at some point, but if you want to just have a quick look at it, print it out and have some little flashcards to flip around, then you can go and do that. I am going to go and have my dinner. See you all next week. Bye. If it's your first time watching a live stream, you'll not yet be aware that I have no idea how to switch these off. I've done a live stream every week for the last 2 years, which is about 100, and I always struggle to find the button that switches it off. That one, let's try that one. Bye.